Good morning, good afternoon, or good evening, depending on what time you're watching this. Now, today's topic is rationalising the denominator. And that simply means writing the denominator as a rational number, i.e., not a surd. So let's do some examples. Rationalise the denominator in the following questions. So if we start with 1 over root 2, and we're asked to rationalise the denominator, root 2 is what we have as a denominator, and that is a surd. So that denominator does not, it has an irrational number and we want to rationalise it. Now, how do we do that? Now, if you can think of, if I have the number 6 and I multiply it by a number, and the answer is 6, what would that number be? If I had 10 times a number and my answer is 10, what would my number be? Now, can you see that the number that was in that box has to be 1, doesn't it? 6 times 1 gives me 6. 10 times 1 gives me 10. So if I multiply any number by 1, I am not changing it. It remains the same. So I want to multiply this 1 upon root 2 by 1. But I don't want to write it as 1. I want to write it in a disguised form. If we have 1, it's not the only way we can write 1. We know that 1 is equal to 10 over 10. Is equal to 100 over 100, is equal to 56 over 56. In fact, anything over itself is equal to 1. So do you agree that root 2 over root 2 is also 1? And that we said if we multiply something by 1, we don't change the value, and we can write 1 in some other form. So let's write this. 1 upon root 2 is equal to 1 upon root 2 times 1. And that doesn't change it, but we're going to write 1 as root 2 over root 2. Now that's absolutely true. 1 upon root 2 times 1 does not change it. Now when we're multiplying fractions together, we multiply the top two numbers together. 1 times root 2 is just root 2. Root 2 times root 2 is root 4. And that's the reason we did that. We know that root 4 is not a surd. Root 4 is 2. It's a perfect square. So that equals root 2 over 2. And that's how we would rationalise the denominator. Let's go through that one again. We looked at 1 upon root 2, and our denominator is a surd. It's root 2. Now we want to multiply by 1 so that we're not changing it. But because this is root 2, we want to write the 1 as root 2 over root 2. And then what happens is we end up that we don't have a denominator that's a surd. Okay, let's do a second one. 12 over root 3. Now again, I have a surd as a denominator and it's root 3. So again, I want to multiply by 1, but I want to write that 1 as root 3 over root 3. So I'm not changing the value at all. Now when I multiply the top two together this time, 12 times root 3, I get 12 root 3 over root 9, which is equal to 12 root 3 over 3, because root 9 is not a surd. Now this time there's one more step to do, because we can cancel. 3 divides into 3 once, 3 divides into 12 4 times. So if we did that, we would get 4 root 3 over 1, and that's just 4 root 3. Oops, sorry, I'm writing that like that, 4 root 3. And this time we don't even have a denominator, but in the last line, the denominator would be 1, so we have rationalised the denominator. Okay, let's do a third example. Now this time, when we're asked to rationalise the denominator, on the denominator we have 3 root 5. Now if we multiplied by 3 root 5 over 3 root 5, that would get rid of the surd, but it would leave us with a lot of cancelling, because that's still 1. So we don't have to do that, we just have to look at what is the surd, and the surd is root 5, so we don't have to multiply by that. We just have to multiply by root 5 over root 5. That's also 1. So let's do that one then. We've asked to rationalise the denominator. It is not a rational number at the moment. 5 root 3 over 3 root 5 is equal to that times 1, except our 1 is going to be written as root 5 over root 5. Now, as before, we multiply the top. That's 5 times root 3 times root 5. And in the bottom, we've got 3 times root 5 times root 5. So that's equal to 5 root 15 over 3 times root 25. So that would be 5 root 15 over 3 times 5. 5 root 15 over 15. Now again, there's two things you would do here. You would check is there any cancelling in the whole numbers, and there is. 5 divides into that once, 5 divides into that 3 times. So we would have root 15 over 3. The next thing you would do is check, does that root 15 simplify? To write that out a bit clearer. So that would be root 15 over 3. And remember, we can simplify Surds. So you would have a wee check. Are there two numbers that multiply to give 15, one of which is a perfect square? And there's not this time. So that's us finished, root 15 over 3. So that's the topic there. Rationalise the denominator. You look at what the surd is in your denominator, and you're multiplying by 1, except you express 1 in the last case here as root 5 over root 5.